Welcome to our educational channel. Today we explore the iconic Giza pyramids and their construction secrets. How did a civilization without modern technology erect such monumental structures? Let's find out. One mystery is how the Egyptians moved massive limestone blocks, some weighing up to 80 tons, from quarries to the construction site. Imagine the logistics and manpower required. One theory suggests ramps. Archaeologists believe the Egyptians built massive ramps of earth and brick leading up the sides of the pyramids. These ramps stretched for hundreds of meters, sloping upwards to allow workers to move the stones. Picture teams of workers hauling these colossal stones along the ramps. They likely used sledges, wooden platforms designed to slide over surfaces with reduced friction. Evidence suggests the Egyptians may have lubricated the ramps and sledges with water or even milk to reduce friction. These ramps likely incorporated switchbacks, a series of zigzags, to make the incline more manageable. This method, while labour-intensive, was within the capabilities of the ancient Egyptians. It speaks to their organisational skills and ability to mobilise large workforces, but ramps and sledges were only part of the equation. Once the blocks reached the desired height, they still had to be manoeuvred into precise positions. Imagine the precision required to place these massive stones with only simple tools. The Egyptians were masters of precision, as evidenced by the near-perfect alignment of the pyramid sides with the cardinal points. The use of rollers, wooden cylinders placed under the sledges, would have aided in moving the blocks horizontally. By shifting the rollers as the block moved forward, the Egyptians could precisely control its placement. It was a delicate dance of manpower, engineering, and ingenuity. While ramps and sledges moved blocks horizontally and up lower levels, lifting them to the top required more ingenuity and advanced techniques. The Egyptians likely used a combination of leverage and counterweights to achieve this feat. Picture a system of ropes, pulleys, and wooden levers working in harmony to lift heavy limestone blocks to great heights. By attaching ropes to the blocks and passing them over wooden beams, workers could pull down on the ropes using their weight and leverage to lift the blocks. This method, known as a simple crane, allowed a small number of workers to lift heavy weights efficiently. The Egyptians likely incorporated counterweights into their lifting systems to further enhance their efficiency. Imagine large baskets filled with sand or stones, attached to the opposite end of the lever system, acting as counterweights. As workers pulled down on their end of the ropes, the counterweights would rise, offsetting the weight of the stone block. This balancing act made lifting the blocks easier, requiring less brute force and more strategic planning and coordination. The Egyptians likely adjusted the positions of the levers, pulleys, and counterweights as the block was lifted, ensuring a smooth and controlled ascent. It was a symphony of physics, a testament to their understanding of basic mechanical principles and their innovative spirit. This was backbreaking work requiring immense strength, coordination, and unwavering focus. Imagine the teamwork and communication needed to ensure everyone's safety and the successful completion of the task. The use of leverage and counterweights wasn't limited to lifting blocks vertically. It was also crucial for horizontal movement. These techniques were likely used to maneuver stones horizontally, especially when placing them high up on the pyramid with precision. Imagine a block suspended in mid-air, held by a complex system of ropes and counterweights ready to be placed. Workers on scaffolding would carefully guide the block into place, using ropes to adjust its position with precision and care. It was a high-stakes operation requiring steady hands, nerves of steel, and meticulous attention to detail. Let's delve into the intricate structure of the Giza pyramids, specifically focusing on the Great Pyramid of Giza. From the outside, they appear as solid geometric marvels, but their construction involved a fascinating interplay of inner support and outer elegance, a true testament to ancient engineering. At the heart of each pyramid lies a core, a stepped structure built meticulously in horizontal layers. These layers, often composed of rough-hewn blocks of local limestone, formed the backbone of the pyramid, providing essential stability and support. Imagine a giant, meticulously crafted staircase rising towards the heavens, each step a crucial part of the whole. To fill the spaces between the steps and create a more solid mass, the Egyptians used a combination of rubble, smaller stones, and sand, a method both practical and ingenious. This infill strengthened the core and helped distribute the pyramid's immense weight more evenly, ensuring its durability over millennia. Think of it as a giant jigsaw puzzle, with each piece playing a crucial role in the overall stability and integrity of the structure. To achieve the pyramid's smooth, sloping sides, the Egyptians applied an outer layer of casing stones, a process that required immense precision. These stones, made of finer-grained white limestone quarried from Tura, were carefully cut and polished to create a pristine, gleaming surface that could reflect the sunlight. Imagine the contrast, the rough, uneven surface of the inner core, hidden beneath a skin of dazzling white limestone, a striking visual transformation. The casing stones were meticulously fitted together, often without mortar, their weight and precise angles contributing significantly to the pyramid's structural integrity. Over time, much of this outer casing has been stripped away, revealing the stepped core beneath, a glimpse into the pyramid's inner workings. Natural weathering, erosion and human activity have taken their toll, yet the pyramids stand resilient. Yet even in their partially unclothed state, the pyramids continue to inspire awe and wonder, drawing countless visitors from around the world. The placement of the casing stones was a meticulous process, requiring skilled craftsmen and precise measurements, a true art form in itself. Each stone had to be carefully shaped and fitted to create the pyramid's smooth, angled sides, a task that demanded both skill and patience. The Egyptians likely used copper tools along with a brace of sand to shape and smooth the casing stones, a technique that was both innovative and effective. These tools, while primitive by today's standards, were capable of achieving the level of precision evident in the pyramid's construction, a remarkable feat of ancient engineering. The casing stones were not all uniform in size or shape, adding to the complexity of the construction process. Stones at the bottom were larger and heavier to support the weight above, while those higher up were progressively smaller, a clever design choice. This gradual reduction in size contributed to the pyramid's overall stability and aesthetic appeal, creating a harmonious and balanced structure. Imagine the carefully orchestrated processions of workers hauling these massive stones on sledges, navigating the ramps and hoisting them into place with ropes and levers, a true testament to human ingenuity and teamwork. The Giza pyramids reflect the Egyptians' deep understanding of astronomy and their profound connection to the cosmos. The precision with which these monumental structures are aligned with the cardinal points, north, south, east and west, is truly astonishing. During the annual flooding of the Nile, the setting sun would cast the pyramid's shadow directly westward, aligning perfectly with the river's flow, creating a breathtaking spectacle. This alignment reflected the Egyptians' profound belief in the cyclical nature of life, death and rebirth, a concept deeply embedded in their culture. The alignment of the pyramids with certain stars has captivated astronomers and historians for centuries, sparking endless curiosity and research. The air shafts built into the Great Pyramid, once thought to be mere ventilation shafts, are now believed to have served a significant astronomical purpose. These shafts, originating from the King's Chamber and the Queen's Chamber, point towards specific stars in the night sky, further emphasizing their astronomical significance. One shaft is aligned with Thuban, a star in the constellation Draco, which was the North Star during the Old Kingdom period, guiding the ancient Egyptians. Another shaft points towards Alnitak, a star in Orion's belt, adding another layer of celestial alignment. The Egyptians associated Orion with Osiris, the god of the underworld and rebirth, linking their mythology with the stars. By aligning the pyramid with Orion, they symbolically connected the pharaoh's tomb with the celestial realm, ensuring his journey to the afterlife. The precision of these alignments is remarkable, especially considering the limited tools available to the Egyptians at the time. They likely used a combination of naked eye observations, plumb lines, and a device called a merket to measure the position of stars with incredible accuracy. The astronomical alignments offer a glimpse into the Egyptians' sophisticated understanding of the cosmos and their place within it. These alignments raise intriguing questions about the deeper symbolic meaning behind the pyramids' construction and their connection to the heavens. The Giza pyramids are enduring testaments to the ingenuity, creativity, and spiritual beliefs of a civilization that continues to captivate our imaginations and inspire awe. The construction of the Giza pyramids remains one of the most remarkable achievements in human history. These monuments stand as a testament to the power of human collaboration, innovation, and the enduring allure of the cosmos. Thank you for joining us on this journey into the past. Stay tuned for more fascinating insights into the world.